everybody. Kelly the Lionfish Hunter here. Had a question from a friend on Facebook about partial pressures, PPO2 and PPN2, and the difference between them. He's doing his Enriched Air course and wanted some clarification between the two. The way I typically teach it is partial pressure is just another way to indicate how many particles of a given gas you're breathing per breath at a given depth. We determine this based on the quantity of oxygen, the percentage of oxygen on the surface of your gas mix, and the pressures that you dive to. So, as an example, we breathe 21% oxygen and 79% nitrogen here on the surface under 1 atmosphere. When we go down to 33 feet, that atmosphere is increased twofold. So it's now 2 atmospheres as opposed to just the one we're experiencing on the surface. For every 33 feet, we experience an additional atmosphere of pressure under the body. And what that does is it compresses the air per breath when you breathe it in. So when we're breathing 21% oxygen on the surface, you can compare that to breathing 21 particles of air per breath on the surface. So when we go down to 33 feet, now you're breathing double that because you're under 2 atmospheres worth of pressure. So 2 times 21 particles of oxygen per breath, that's going to be 42. And we'll express that as a partial pressure by changing it to a decimal. So now we're breathing a PPO2 of 0.42, and so forth and so on. As we get down to 66 feet, now we're breathing in 0.63. We have a 0.63 PPO2. And the same process occurs with nitrogen, helium. It doesn't matter what gas. Any gas can be substituted. So when you hear PPN2, that's simply the partial pressure of nitrogen. So for an example, on the surface we're breathing 79% nitrogen. We can express that as a PPN2, a partial pressure of nitrogen squared, as 0.79. So we have a PPN2 of 0.79 on the surface. And again, when we go down to 33 feet, we're adding another atmosphere, so we're doubling our pressure, and that's going to give us a partial pressure of nitrogen of 1.58. So this is how we do the math to determine what our partial pressure is of each gas that we're breathing at a given depth. And this holds true for helium also with trimix diving. It's any gas breathed under pressure. It's the same process you'll work through the math. Now we also have the topic of maximum operating depth when you're looking at enriched air, and you're looking at an equivalent air mix, or equivalent air depth, I'm sorry. And then you also have the equivalent narcotic depth. So your maximum operating depth is going to be with a partial pressure of no greater than 1.4. And that's the limit, the threshold of partial pressure that science has determined. Very, very few people, if any, will get bent or have any kind of problems with that particular gas at this partial pressure. So for each gas is different. For air, the danger is, for oxygen, the danger is oxygen narcosis and oxygen toxicity. Both of those are serious and need to be dealt with immediately. Fortunately, you can deal with them immediately simply by coming up and relieving the pressure, which lowers the partial pressure of that gas. So oxygen has a partial pressure of 1.6 as its as the absolute maximum limit that you can go to for contingency. We call that the contingency limit. And like I say, it's 1.4 is your maximum operating depth when you're doing your math and you're trying to figure out how deep can I go safely on this gas mix. Your oxygen is going to limit you to a 1.4 partial pressure, and nitrogen toxicity, nitrogen narcosis, we all know it occurs at about, the danger begins at around 90 feet, 30 meters. And that partial pressure, if you do the math, is going to be just over 3.0 ppm2. So you can also look at it that way. Although it's typically not taught as a ppn 2 of 3.0 or 3.1 being the narcotic limit. We just say 90 meters, or I'm sorry, 30 meters, 90 feet, or 100 feet, because it's simpler and it's easier for most entry-level students to understand. So there you have it. PPO2s in a nutshell. Let me know if you guys have any more questions, and thanks for watching.